Shubhamangalam, academic scholar. Myself, Sudeep. I'll be taking up class 10 for today. I'll be taking up physics for you. So we were done with the chapter number 1, reflection of light at curved surfaces. We need to do the study material. So I want you to open up this book of yours. This is a study material, and you need to open it through exactly half of it, because in the initial beginning lessons and all, you just have the theoretical explanation, and whereas just right in the middle of the book, it is page number 20 again, starts like this. I'll show it to you so that it is a bit clear where should you start. Okay, right after page number 183. After page number 183, you have page number 1 again. Okay, do you understand? After page number 183, you have page number 1 again, and from here you need to turn to page number 20, where you have your objective type questions that we are going to discuss now. I've mentioned the page number 20 to page number 27. This is after page number 183, right in the middle of the textbook. Can you see how many pages I've taken? Okay, we are just in the first chapter. Still, I've taken the middle of the book. Did you understand the logic over here? You need to open up the middle of the book to spot or identify the objectives over here. It is page number 20. The book is a bit varied this time, this year. It's fine. Okay. So let's do the objectives together, class. The ratio of the focal length of spherical mirror to its radius of curvature. Page number 20, the first question, I'm repeating it again. The ratio of the focal length of the spherical mirror to its radius of curvature. How is the focal length denoted as F? How is the radius of curvature denoted as R? So R is also written as 2F. Yes or no? If I cancel F and F, I will get 1 by 2. 1 by 2 can also be written as 0.5. Yes or no? If you have a pencil with you, please note down this explanation also near the bit over there. First one answer is A. Second one. Okay, the object distance U, image distance V, and the focal length F for a spherical mirror are related as. Basically, they are asking us to write down the mirror formula. What is the mirror formula, class? 1 by F is equal to 1 by U plus 1 by V. So what is the option? Second one is option B. Okay, third one, the image formed by a concave mirror is always real or is always virtual? Can be both real and virtual, none of these. What do you think? We have discussed so many cases, so many ray diagrams, like 5 or 6 ray diagrams for concave mirrors. What did you conclude from that? Do I get a real image in that? Yes, you get a real image when you're placing the object beyond C, at C, between F and C. What after that? If you place the object between P and F, what kind of image are you getting? Virtual. Did you understand? So this means both real and virtual images can be formed with the help of concave mirrors. And what is the super explanation of that? Ray diagrams, of course. That's the best example that you can use. So third one is option C, class. Fourth one. Okay, the image formed by a convex mirror. You need to understand this. There were 3 rules pertaining to convex mirrors. Rule number 1, 2 and 3. So these rules, as per these rules, only a point-sized or a diminished image is formed with the help of a convex mirror. It is always going to be lesser in size. Whenever you are using a convex mirror, the resultant image of the original object is going to be diminished in size. Okay, and it is always going to be virtual, not inverted. So it is, fourth one is option C. We have already discussed the 3 rules while I was teaching you the lesson. Please go through that. The mirror which has a wide field of view. Now when you are driving and when you are driving a motorbike and you have the rear view mirror in front of you, what is the field for this rear view mirror? It is going to view whatever is there behind you. Yes or no? So the field for this rear view mirror is huge. It can, show a huge truck behind you as a very small image. Do you understand? So the area or the field of view for the convex mirror is really small. Okay, the area or the field of view for the rear view mirror is really huge. Did you understand? What am I saying? Let me repeat it again. Look at the question. The mirror which has a wide field of view. What do you mean by wide field? Okay, when you are using a rear view mirror, you can see huge trucks which are behind you as small images. Okay, those huge trucks are actually in a very big field. Do you understand? The area behind you is really huge, but you can see the entire area or the vehicles in that particular picture as a very small or diminished image. So this means the rear view mirror is able to show you a smaller size of the huge picture or huge vehicle behind you. So it is the convex mirror which is having a wide field of view. Even though it is having a wide field of view, it is able to show you a clearer picture because it is reducing the size of the image. Do you understand? So what is the answer for this? The answer is it is a convex mirror. Sixth one. A real and inverted image of the same size. Same size, always please print it in your mind. Same size is always going to happen when you are going to place the object at the center of curvature. On page number 17 in your textbook, you are going to learn the table thoroughly. Okay, it is going to explain you where are you going to place the object and what kind of images are going to be formed. So same size, whenever you see this keyword, the answer is always going to be that the object is placed at the center of curvature. Let's look at the question again. A real and inverted image of the same size is formed by a concave mirror when the object is placed at the center of curvature. So sixth one is option C. Seventh one. The driver's mirror, I just discussed with you. The rear view and the car mirror of the driver is always going to be convex because you need to see a wider field of view behind you. Did you understand? So, seventh one is option A. Eighth one, a concave mirror always forms real and inverted image except, between which case, except when the object is placed between the pole and the focus. When the object is placed between the pole and the focus, the image is going to be virtual and behind the mirror. So eighth one is option D. Okay, between the pole of the mirror and the focus. Ninth one. An object is placed at a distance of 30 centimeters from a concave mirror of focal length 15 centimeters. What do you think is going to happen? The focal length is given as 15 centimeters. Okay. What is the focal length given as? 15 centimeters. What is the formula for radius of curvature? R is equal to 2f. So what is the 2f value now? 2 into 15, which is nothing but 30 centimeters. Okay, the focal length was given as 15 centimeters. You know that the radius is nothing but 30 centimeters. Okay, how do you calculate radius? If this is the concave mirror and this is your pole, this is your focus, this is your center of curvature, the distance between the pole and the center of curvature will be called as the radius. Did you understand? And how much is this length given as? 30 centimeters. How much is the focal length given as? 15 centimeters. With the help of focal length, we were able to identify what is the radius. Yes or no? Okay, now look at the question again. An object is placed at a distance of 30 centimeters from a concave mirror. This means the object is placed at the center of curvature. Yes or no? Because it is placed at 30 centimeters from the pole of the concave mirror. What is at 30 centimeters from the pole of the concave mirror? It is nothing but the center of curvature. This means the object is placed at what? At the center of curvature. So what would be the nature of the resultant image then? It is going to be real, inverted and same size. Yes or no? Okay. Ninth one. Ninth one is A. If I place the object at the center of curvature, the resultant image is going to be real, inverted and same size. Please learn the table on page number 17. Now, 10th one. Okay. Page number 21, 10th question class. Starting from a long distance, a flame is moved towards a convex mirror. As you come closer to the mirror, what is going to happen to the image? It is going to become magnified. It is going to become bigger. So then the image increases in size and moves towards the pole. Yes or no? If this was the, okay, they are talking about convex. If this was the mirror and this was the object, I am bringing the object very close to the convex mirror. So what will happen to the image in the convex mirror? It is going to be bigger in size because you are bringing the object closer. Yes or no? And what is just going to happen? It is going to come towards the pole. So 10th one is option B. Yes, it's option B. 11th one. Okay, the laws of reflection of light. What are the two laws of reflection of light? Angle of incidence is equal to angle of reflection, and all the three rays. What are the three rays class? The incident ray, the normal ray, and the reflected ray lie on the same plane. So the law of reflection of light are valid for all the reflecting surfaces, whether it is plane mirror or whether it is spherical mirror. Both the laws of reflection are going to be proved and valid. Did you understand? So you are going to write 11th one, option D. 12th one, the ratio of the size of the image to the size of the object. What was the formula of magnification? Magnification M is equal to HI by HO is equal to minus V by U. What is HI over here? Height of the image. What does the H word HO represent? It represents height of the object. So they are asking us, what is the ratio of the size of the image to size of the object? Size of the image is nothing but height of the image. Size of the object is nothing but height of the object. So what formula are we talking about? We are talking about magnification formula. So 12th one is option A. Okay, please note it down. Yes. So 13th one, in the case of dash mirror, the magnification is always positive. When is the magnification always going to be positive? What do you think? When the image is going to be upright. Did you understand? And in what cases the image is going to be upright? When the image is virtual. In what cases is the image always going to be virtual? In a convex mirror, the image is always going to be virtual. Concave has just one case of being virtual, whereas convex, wherever the object is going to be placed, the resultant image is always going to be virtual and diminished. So here, the 13th one is option number C. Okay, for a real and inverted image, magnification. What did I say you? Just the previous question is explaining us why is the magnification positive. The magnification is positive because the image is upright. Now in the next question they are asking us, for an inverted image, what is the magnification? For anything below the principal axis, the sign that you are going to write is negative. Yes or no? Definitely the magnification also becomes negative. So now the 14th one is A. Okay, 15th one, for a virtual and erect, if the image that is being formed is on the principal axis and it is virtual and erect, then the magnification is going to be positive. Repetitive questions class, please try to understand. If the image is upright and it is erect and it is virtual, then the magnification is going to be positive. If the image is real and inverted and below the principal axis, then the magnification is going to be negative. Okay, so 15th one is option B. Let's look at the 16th one. Dash image cannot be caught on the screen. Only real images can be caught on the screen. What are the other kind of images? It is virtual images. Where are they going to be formed? Behind the mirror. So which images cannot be caught on the screen? It is the virtual image, and it is option B for now. Okay, now the 17th question on page number 21 class. I will read it out for you. Which of the following mirrors is used by dentist? Okay, now the dentist needs to have a wider picture of your tooth. So what kind of mirrors is he going to use? He is going to use concave mirrors because concave mirrors are going to give you a bigger picture of your tooth or teeth. Okay, the set of teeth that we're talking about over here. So it is concave. So this means the dentist is going to place the mirror between the pole and the focal length. That is why he's able to view a virtual and enlarged image. Okay, so 17th one is option C. The same thing happens with shaving mirrors also. It is the concave mirror used on that because they're going to see the slightest of hair by placing it very close and then shave it off in saloons with the guys, not the girls. So 18th one, mirror formula. Okay, what is the mirror formula class? 1 by F is equal to 1 by V plus 1 by U. So 18th one is D. 19th one. When light gets reflected from a surface, if the angle of incidence is 30, what is the angle of reflection? Really easy class. What is the first law? Angle of incidence is equal to angle of reflection. They have given us angle of incidence as 30 degrees. So what is going to be angle of reflection? As we know, angle of incidence is equal to angle of reflection. Okay, so angle of reflection therefore is equal to 30 degrees. So what you can note this down if somebody was unaware of how did we get 30 as an answer. Please note this explanation down in your textbook, or else write it in a paper and stick it as a sticky note. Okay, 19th one is option A, 20. Please turn the page to page number 22, class. Okay, so now page number 22, objective number 20. Which of the following image cannot be caught on the screen? Which images cannot be caught on the screen? Virtual. Which images can be caught on the screen? Real. So 20 is option C. 21. When parallel rays are incident on a concave mirror, on reflection they meet. What did I say you? Focus and the parallel rays always go hand in hand. If this is my concave mirror, this is the pole, this is the focus, this is the center of curvature. I have parallel rays coming from a certain source. For example, what is it? Sun. Okay, if I have parallel rays coming from the sun, they are nothing but the incident rays. They are going to be projected on the mirror. They are going to meet at a certain point, and they are going to get reflected and pass through the focus. Okay, the reverse also happens. What is the reverse? If this is the pole, this is the focus, this is the center of curvature. What does this mean? If this parallel ray passes through the focus, then the reflected ray is going to be parallel to the principal axis. These were the two rules that we are using to draw array diagrams. Do you remember that? The parallel rays which are coming from infinity and the focus always goes hand in hand. If the object is placed at infinity, the image is going to be formed at the focus. This means the reflected ray is going to pass through the focus. If the object is placed at the focus, the reflected ray is going to be parallel to the principal axis and the image is going to be formed at infinity. Okay, so 21st one is option A. 22nd one. Which of the following is the formula for magnification? We just discussed it. M is equal to hi by h naught, height of the image by height of the object. Option B. 22nd one. 23rd. An object of size 7 centimeters is placed at 27 centimeters. So they have given us a problem over here that we will try to solve. So height of the object is given as 7 centimeters. Okay. So now it's placed at 27 centimeters in front of the concave mirror. They have also given us the object distance, which is 27 centimeters. They have mentioned that the object is placed in front of the concave mirror. This means we are going to measure the distance from the pole. And the object is placed somewhere over here. If I measure the distance from the pole, this means I'm going against the incident light. So the object distance is going to be taken as negative. Okay. So what else are they going to ask us? An object of size 7 cm is placed at 27 centimeters in front of a concave mirror of focal length 18 centimeters. In front of the concave mirror, focal length is also on this side. I'm going to measure all the distances from the pole. Okay, if I measure the focal length also from the pole, which I have to do because the focal length is always on this side for a concave mirror. For a convex mirror, it is going to be on this side. But for a concave mirror, it is on this side itself, and I start measuring from the pole till the focal point. The focal length is also considered as negative. F is equal to minus 18 centimeters. Did you understand? So they are asking us to find out the image distance. Okay, so what formula am I going to use? 1 by f is equal to 1 by v plus 1 by u. So this is 1 by minus 18 is equal to 1 by v plus 1 by minus 27. Okay. So this was what I was telling you. I'm going to use the mirror formula. 1 by f is equal to 1 by v plus 1 by u. What do I need to find out? I need to find out the image distance. So the focal length is given as minus 18 centimeters. The image distance, of course, you are going to write it as v again. The object distance is given as minus 27 centimeters. So the next step, 1 by minus 18 is equal to 1 by v minus 1 by 27. If I bring this minus 1 by 27 on this side, what is going to happen? It is going to become plus. So 1 by 27 minus 1 by 18 is equal to 1 by v. I told you an easy method of LCM. Do you remember? So it is 18 minus 27 by 27 into 18 is equal to 1 by v. Okay with everyone? What is 18 minus 27? What do you think it is? Of course it is minus 9. So minus 9 by 27 into 18 is equal to 1 by V. 9 ones are, 9 threes are. What is 18 threes are, class? It is minus 1 by 54 is equal to 1 by V. Let's take a reciprocal. So V is equal to minus 54. This means centimeters. Remember that. Okay, so the image distance is nothing but 54 centimeters, and that minus indicates what? That the image is formed in front of the concave mirror. Did you understand? If there would be no minus over there, this means the image will be behind the concave mirror. Okay, the minus 54 centimeter indicates that the image is formed in front of the concave mirror. Again, you will be measuring the distance from the pole. Anything measured against the incident light is always going to be negative. So what answer are we going to mark over here? 23rd one is option D. Please note down this explanation over here so that you don't get confused when you're studying for your exams. So which of the following mirror is used by Archimedes to burn the ships? You should be knowing this. I also drew the diagram for you on the board while I was explaining you. So 24th is option D. 25th one. Which of the following is the formula of magnification? Hi by h naught is equal to minus v by u. So which option, class? 25th one is option C. Okay, 26th one. An object of size 7 centimeters. The same problem, class. Is placed at 27 centimeters in front of a concave mirror for a focal length 18 centimeters. Find the size of the image. They are not asking us image distance this time. They are asking us the size of the image. But to find out the size of the image also, you need to know the image distance. So it's good that you have done the problem already. So what is the formula of magnification? Hi by h naught is equal to minus v by u. Hi is something that needs to be found out. Ho is given as 7 centimeters. So hi by 7 is equal to minus of, what is the image distance? Minus 54 divided by minus 27. That is nothing but the object distance. Cut one set of minus. Okay, 27 ones are, 27 twos are. So hi is equal to minus 2 into 7. Minus 2 into 7 is how much, class? Minus 14 centimeters. Okay, please note that thing down. So yes, 26th one is option A. Okay, 26th one is option A. Okay, 27th one, class. Where the image is formed when the object is placed between the mirror and the focus. When the object is placed between mirror and the focus, this means the object is placed between P and F. The mirror is nothing but the pole of the mirror, no? So yeah, so what happens when you place the object between the pole and the focus over there? You get a virtual image. So you get the image behind the mirror. A virtual image is always formed behind the mirror, class. So 27th one is option B. 28th one. At where the, good English, really, this is something really different, next level. So question number 28, at where the object is placed, it should be actually at which position the object is placed. It's fine, please ignore this. At which position the object is placed on the principal axis of a concave mirror, we get the image at infinity. What did I say you? Infinity and focus always go hand in hand. In the question they are asking you infinity. This means where is the object placed? Focus. So 28th one, option D. That is nothing but the focal point or focus. 29. At where the object is placed to get a same size of the image and is inverted. Same size, class. I told you to remember the keyword for same size. It is the center of curvature. So 29th one is option C. 30. Which mirrors are used in vehicles as rear view? Just discussed. It is the convex and window glasses of a car. 30. Option A. 31. Where is the object placed to get a virtual image behind the concave mirror? Only one case you are going to get a virtual image in a concave mirror when you place the object between P and F. Okay, between the mirror and the F. So 31. Between P and F and between mirror and F is the same thing. Remember that. Because P is present on the mirror. Okay. Pole is nothing but the midpoint or the geometric center of the mirror that we are talking about. So the answer is 31B, between mirror and F. 31B. 32. Which type of mirrors are used in the headlights of the vehicle? So you want to have a broader light, even if you're using a small bulb in the headlights. Okay, so to have a broader light, what kind of mirrors will I be using in the headlights? It is parabolic. Remember, what is it? Concave. Okay, 32 is option A. You need to, compare the shapes of the dish antenna, the headlight mirrors, and, and then you understand why are we using concave over there, to get a wider image and enlarged light, so that you can, use the headlights during the dark while traveling in lots of traffic or something like that, or else if you are on a highway. 27, is it done? Yes. 32 is done. 33. Come to page number 23. Page number 23, 33rd objective. When parallel rays are incident on a concave mirror, on reflection, they meet at the focus. Yes or no? When the parallel rays are incident, the resultant rays or the reflected rays are going to meet at the focus. So 33rd is option B. 34. What is the radius of curvature of the mirror if the focal length is 20? What is the formula? R is equal to 2F. So twice the focal length gives me the radius. Twice the focal length. What is the focal length given as 20? So 2 into 20 gives me how much? 40. So 34th one is option C. 35. An object is placed at the center of curvature of the concave mirror. The distance between the image and the pole. What is center of curvature? P to C. P to C is nothing but the radius. Radius is equal to 2F. So 35 is option B. 36. F is equal to R by 2. They have just altered the formula. Try to understand. R is equal to 2F. Okay, R by 2 is equal to F. Just altered it a little bit. So F is equal to R by 2 is valid for both convex and concave mirrors class. Okay, both the spherical mirrors, this is going to be valid. So it is option C. 37th one. A mirror forms a virtual image of a real object. Okay, it can be a convex mirror, it can be a concave mirror, it can be a plane mirror, it may be of any of these mirrors. It can be any of these mirrors class. Okay, every day that you see the dressing table mirror also gives you a virtual image. Convex mirrors, in all the cases, they are going to give you a virtual image. And to remember, concave mirror, in one case, it still gives you virtual image when you place the object between P and F. So 37th one is option D. 38. To get an image larger than the object, one can use. If you want to get a larger image, which kind of mirror will you be using? Convex is going to give you diminished. So which mirror is left out? Concave. So option B, concave, not convex. 39th. A concave mirror has a focal length of 25. A person wants to see his face in the mirror. Okay, if you want to see the face in the mirror, this means it needs to be upright and virtual. Yes or no? In what case can the concave mirror give you virtual? When the object is placed between P and F. This means he needs to place his face between P and F, very close to the mirror. The focal length is already given as 20. So the answer should be something less than 25. Yes or no? The focal length is already given as 25. The person needs to place his face at a distance which is something lesser than 25. Which option is lesser than 25? Option C, 20. Okay. Question number 40. Shaving mirrors, dentist mirrors. Already discussed. Which kind of mirrors? Concave. So where is the object being placed P and F to get a very big image? 40 is option D. 41. Concave mirror is a part of the sphere. That is why they are called as spherical mirrors. So 41 is option D. 42. The center of the mirror is called the pole. Okay, option number B. 42. 43. We get a virtual image with a concave mirror when the object is placed between the pole and the focus. Here the pole is also referred as vertex. Vertex is a mathematical terminology just to trick you. So 43rd is option A. Okay class. Sorry about that. 44. Come to page number 24 and question number 44. Scientists who used mirrors to burn ships, Greeks versus Romans. Who was the Greek guy? It was Archimedes. The mirror used by ENT. ENT is ear, nose and throat specialist. They are going to use concave mirrors to have a clearer view of your internal ear, the throat and the nose. So 45 is option B. 46. So by now you have three uses of concave mirrors. They are used by shaving, they are used as shaving mirrors, they are used by dentists, they are used by ENT specialists. And what uses do you have of convex? They are used as the driver mirror, they are also used as the rear view mirror. Okay. So the image formed due to a concave mirror is highly enlarged when the object is placed, highly enlarged when the object is placed at the focus. Okay, because the image is going to be formed at infinity. You cannot determine the size at what kind of image is going to be formed at infinity. It's going to be very, very large. Okay, so 47th one, a concave mirror forms a point-sized image for an object placed at infinity. If the object is placed at infinity, the resultant image is going to be at the focus, which is going to be point-sized. Okay, refer page number 17 table. All this is already there in that. Okay, 47th is option B. 48. Radius of curvature is dash its focal length, twice its focal length. So 48th one, just discussed class. It's this very simple formula. The geometric center. Okay, wait, I'm sorry. 49th one. The center of the sphere to which a spherical mirror belongs. Center of the sphere is also called as center of curvature. Curvature. It is nothing but referring to a curved surface. What is the curved surface are we talking about? The sphere. Okay, so 49th one is option C. 50. The geometric center, also called as the pole. 50 is option B. The geometric center of the mirror is nothing but the pole.